What's going on, Kipsters? I miss y'all. I hope y'all are doing okay. I want to drop in a short little video with 3 examples, and we're going to be talking about equations. Equations. You can say it with me, equations. So here's the first sort of definition of equation, if this is your vocabulary word. It's a math statement showing that both parts are equal. Don't make it more complicated than it is, but it is a math statement showing that both parts are equal. Here's my first example problem. Luann has a piece of ribbon that is 39 inches long. She cuts off 33 inches to tie a gift box. How many inches are not used? Luann has a piece of ribbon that is 39 inches long, and she cuts off 33 inches. How many inches are not used? So let's figure out the equation so that we could solve the problem. The equation is going to help us solve. I'm going to slide this up just right here. Luann has a piece of ribbon that is 39 inches long. She cuts off 33 inches. How many inches are not used? So we have 39 is the whole. 33 is one of the parts, and we need to figure out this other part. So to come back to that, every time we have a whole and one of the parts, we need to use subtraction. Put a big subtraction symbol. So let's come back and figure out what the actual equation is to solve it. This is kind of the reading and the drawing part. Now we need to write down what the equation might be. So let's do 39 minus one of the parts, which is 33, and that would equal the other part. Right there. So 39 minus 33. Let's do it right here. 39 minus 33. One side first. 9 minus 3, 6. 3 minus 3, 0. Do I need to write the 0? No. 6 inches are left. 39 inches minus 33 inches equals 6 inches. This right here is the equation. Before we solved it, the equation looked like this. These are the equations. This is the drawing and the writing it out, but this is the actual equation. Remember, an equation is a statement that shows both parts are equal. So 39 minus 33 is equal to 6. Nice. Let's do another one. I'm going to clear the board. Next example is going to be in red. Remember, you can pause it whenever you need to. I don't know if I have something to erase it with. Here we go. You can always pause the video to go back and look at my first example, which was written on the orange paper. My second example is going to be written on red. I have 2 more examples. Okay, so here we go. Example number 2. Let's only look at 2 for now. I'll fold this over. Elijah runs 68 yards in a 100-yard race. How many more yards does he have to run? Elijah runs 68 yards in a 100-yard race. How many more yards does he have to run? Okay, we read it. Let's draw it out. Elijah. He's running. There. Now he's running. Elijah runs 68 yards in a 100-yard race. How many more yards does he have to run? This is how far he ran. The whole race is 100. What does he have left? It's probably more like this. He ran 68 out of the 100. Again, we have the whole 100-yard race. We have one of the parts. Let's figure out what the equation would be. Just like last time, if you have a whole and one of the parts, you know that we need to use subtraction. 100 minus 68 equals, and we don't quite know yet. So this is an unsolved equation. It's not quite solved yet. To solve that, I'm going to write it in vertical form. I'm going to have to unbundle my 100. I have no hundreds. I'm going to have 10 tens up, but I need a ones column. So I'm going to take this down to 9 tens, and this is going to be 10 ones. Now I can subtract. 10 ones minus 8 ones, 2 ones. 9 tens minus 6 tens, 3 tens. 0, bring that down, don't need to write it. 32 what? 32 yards. So 100 minus 68 equals 32 yards. Now, this is a solved equation. Remember, that's what we're talking about. Equations. Equations. An equation is a math statement showing that both parts are equal. There we go. And we got one more for you. A math statement showing that both parts are equal. This is one part of the equal sign. This is the other part of the equal sign. The equal kind of divides it right down the middle. Okay? You have to make sure one side is equal to the other side. I'm going to have to erase Elijah. Alright, here we go. One more example. You can always pause the video if I'm going too fast. That's why I like to use the color sheet so you know which example you're on. Example 1 was on orange. 2 and 3 are going to be on red. Alright, here we go. We have to figure out what equation we can write to help solve the problem. The length of one side of a square is 3 yards. What is the combined length of all 4 sides of the square? Let's go back and circle or underline some key information. The length of one side of a square is 3 yards. What is the combined length of all 4 sides of the square? All right, the square. The length of one side is 3 yards. What is the combined length of all 4 sides? A square. Remember, a square means that all sides are equal. So we know that 3 combined, we're going to add plus side 1. I'm not going to write a 1, but this is side 1, side 2, side 3. Plus one side, plus another side, plus another side, for a total of 4 sides. 1, 2, 3, 4 sides, and we don't know what that equals yet. So this is part of our unsolved equation. Let's go back and solve it. A square means that all 4 sides are the same. So we know if this side is 3, then this side is 3. If this side is 3, this side is 3. Just like that. So you know that all 4 sides are 3. 3 plus 3 plus 3 plus 3. 1, 2, 3, 4 sides. Here is our equation. 3 plus 3, this would be 6. Another 3 plus 3 would be 6. Add those two together, 12. So 3 plus 3 plus 3 plus 3 plus 3 equals 12. So there is an equation example with repeated addition. I combine the 2 3s to 6. I combine these 2 3s to 6. 6 plus 6 is a doubles fact. That is a 12. 12 what? 12 yards. And now it is solved. Boom. 3 examples of 3 different equations. 2 were subtraction, 1 was addition. There you go. That's the end of my video. Adios.